Hey guys, today we're gonna talk about acceleration. It's a pretty simple concept, and well, we hear it all the times in cars, for example. When we say, oh, he's accelerating too fast, he's gonna kill someone, well, of course, that is saying that a car is starting to move faster and faster, which is just simply saying that there is a change, a positive change in velocity. So now, how do we define, real quick, how do we define acceleration? Well, acceleration, which it's a vector, okay, because acceleration can happen in a direction. So acceleration, we define it with the letter A and an arrow because it is a vector, and it's going to be equal to the change in velocity, because remember, acceleration is when you are increasing or decreasing your velocity, which means you're changing your velocity. So you're going to have delta velocity. Remember, delta is just simply saying change, the change in something, divided by the change in time, okay? So now, this is a pretty simple definition, but that is pretty cool, okay? And it's pretty useful. So, for example, let's suppose we have a scenario in which we have two moments, okay? A moment being defined as an instant in which you have specific properties. So let's suppose there is a car traveling. I'm going to draw a car. Let's hope this car looks good. Yeah, that's a cute car. And now let's say this moment, when t equals 0, the speed of this car will be, I'm gonna call it initial velocity, would be equal to 20 kilometers per hour. And now let's say this car, he moved, now in this case, of course, remember this would be a vector. I forgot the arrow. Now I'm going to say that he moved to the east. This is east. And now he's traveling at a speed. Our cute car is now traveling at a speed of, let's say, what about probably 100 kilometers per hour. And let's say this happened in the second, t equals 5 seconds, okay? So now, as I said, let's suppose we have two moments, okay? Or two instants. The first instant, when t equals 0, is the car has an instantaneous speed, velocity. You remember, you need to be very strict. If you have a direction, you're talking about velocity, not speed, okay? So, in the first moment, t equals 0, we have a velocity of 20 kilometers per hour. And then 5 seconds later, we have a velocity of 100 kilometers per hour. Now, how do we quantify, or how do we determine the change in velocity? Well, we compute an acceleration. So we're going to say that in this case, the acceleration would be equal to, so we have the change in velocity divided the change in time. Now, this would be equal to our final velocity minus our initial velocity. That will give us our net change in velocity between these two intervals, inside this interval. And the change in time would also be the net period of time, or the net, you could say duration, not duration, the net, how long this event was, okay? That's what I mean. And this is also final time minus initial time. Now our final speed we knew was 100 kilometers. Initial was 20 kilometers per hour. And our times, so we started at t equals 0, and apparently the car, here, this is a good example for showing you why it is important that you have a good concept of delta t. This car, it is physically impossible that if t equals 0 is when the car is just, at rest, it is impossible that at that moment, or just when a very small amount of time has passed, that the car now has 20 kilometers per hour, okay? That is physically impossible. So this means that at least in the period of time that we are considering when we define t equals 0, before t equals 0, the car had already any type of speed, okay? The car was already accelerating before t equals 0. But we are only considering these 5 seconds. That is why we need to take the net change in time. I mean, I could even say that this is, for example, let's say that is not 5 seconds anymore, but 20 seconds. Okay, and I'm going to see 10 seconds after the car starts moving, what happens. So I'm going to say that my first moment will be t equals 10 seconds. Now it would be different. As you can see, we would get that our final time would be 20 seconds minus 10 seconds. This would be equal to 80 kilometers per hour divided by 10 seconds. And so you're gonna see something pretty cool with these units in here. So in this case, we could be apparently the car, it's moving pretty fast because, well, you could see it's moving 8 kilometers per second, or well, its acceleration is of 8 kilometers per second. But if we wanted to get it in meters per second, we would get a common notation that you may have seen, which is meters per second squared. Okay, now I'm going to show you how we get there. So first of all, we need to transform 80 kilometers per hour into meters per second. We do what we did last time. So we know 80 kilometers would be equal to 80 groups of 1,000 meters, which is what 1 kilometer is. Now this is equal to, this is of course kilometers, don't forget the units, and you would get this is 80,000 meters. And now we have 1 hour, which we know it is 3,600 seconds. This number comes from multiplying 60 minutes times 60 seconds. And now in this case, we would get, you're multiplying here by 100, so you can take away those, and you get 800 meters divided by 36 seconds. Let's see how we could, I mean, I think we have to take halves here. We can't do anything else. So we would get 400 meters over 18 seconds, 200 meters, 9 seconds. Can I 9 times 20? No. Now without using a calculator, this is the smallest number that we can get. Or maybe let me get my calculator real quick. Plug out your calculator and let's see how much that is. 200 divided 9, 22.2 periodic meters per second. 22.2 periodic meters per second. Cool. Now we're gonna use this number in here. So this would be equal to, I'm going to make a space here. So we have, this would be equal to 22.2 periodic meters per second divided 10 seconds. And now once again, in this case, you could bring this fraction all the way like to cover that one. And what you can do in this case, remember that when you're dividing a fraction by something else, you can multiply by the inverse of the divisor that you have. So in this case, what we would get is that we're going to multiply 10 seconds times 1 second and divide by 10 divided 22.2. So we would get 22.2 periodic divided 10, and then we have meters per second. And now we're going to do, what you're going to do is you have the inverse of that, which is just simply 1 on top, we leave it the same, and then we have 1 second times another second. That's where the seconds squared come from. And so you get, this would be equal to, can we take halves? Yeah, we can. So we would have 11.15, yeah, we can't do anything else. So 11.1 periodic over 5 meters per second squared. And now let's see how much acceleration that is. So we have 11.1 divided by 5, 2.2. And that would be equal to, oh, well, yeah, that makes sense, yeah. Because if I had 22.2 periodic, yeah, that's just 2.2. So this is equal to 2.2 periodic meters per second squared, okay? And now from these two steps is where you see the s squared in a acceleration, okay? So I hope you guys understood this, and now we're gonna do probably one problem about acceleration.